Kia ora Year 12. This is going to be a really quick video looking at how we find the second derivative when we are working with parametric equations. So I've got two quick examples here, and all I'm going to do in this video is just the skill of finding the second derivative. When you get to harder problems and exam questions, you'll need to use that skill to do all of the usual kind of second derivative stuff. For example, if you need to check the nature of a stationary point, then you need to look at the second derivative. Okay, so let's have a look at these two here. The first one is a trig example. So x is equal to cos theta and y is equal to cos of 2 theta. We know from parametric differentiation that if we want to find dy by dx, that's going to be equal to dy by dt times dt by dx, which is the same as dy by dt divided by dx by dt. So the first thing we do is we find dx by dt, which will be negative sine theta, and dy by dt, or sorry, dy by d theta, that should all be thetas. Sorry guys, brain going a bit slowly today. Here we go. So that's dx by d theta, and then dy by d theta is equal to negative 2 sine of 2 theta using the chain rule. Okay, so dy by dx is equal to y dash over x dash, right, which is this thing here. So negative 2 sine 2 theta over negative sine theta. And we're going to expand this out using our trig identities, and we get negative 2 times 2 sine theta cos theta over negative sine theta. That gets me to 4 cos theta. Okay, so that's dy by dx. Right, so to find the second derivative, what I want to get is this. So I want d squared y by dx squared. And if you think about when we're doing an ordinary second derivative, so say we just had, I don't know, y equals x cubed plus 45, right? Then dy by dx is equal to 3x squared. Well, what do I mean by finding the second derivative? Well, I mean, take the first derivative, and differentiate it with respect to x. So that's what we want to do here. We want to take the first derivative and differentiate it with respect to x. But we've got a problem, right? Because this thing doesn't have any x's in it. It just has theta. So again, we're going to use the chain rule. And we're going to differentiate with respect to theta and then multiply by d theta by dx. So by using the chain rule, this becomes a really easy problem, right? All we have to do is differentiate this and then times by the reciprocal of this thing here. Okay, so dy by dx was 4 cos theta. The derivative of that will be negative 4 sine theta. And then dx by d theta was negative sine theta. So it's times 1 over that. And that's how we do it, right? So that's our first example, just about done. That gives me all up simply 4. Okay, and you can chuck this into GeoGebra. If you want to know the GeoGebra command to do parametric, it's simply curve, and then you put in the expression, right? So you might put in cos t, cos 2t, then you put in t, and then you put some values in. So I don't know, negative 2 pi up to 2 pi. And you can easily play around with these, okay? And that will draw the curve out for you. And when you look at it, you'll see that you get a parabola. And so it makes sense that what we've got here is a constant second derivative, meaning that if I find the stationary point, it's going to be a minimum, right? But that's more than I really wanted to get into in this video. As usual, I've added in some extra stuff. So now let's look at the second example where we've got x is equal to 1 plus t and y is equal to t times t minus 1. So I'm going to show you how to find the second derivative with this, and then I'm going to show you how we can quite easily, in this case, eliminate t and write this in the form of y being a function of x. Okay, so we've got x is equal to 1 plus t and y is equal to t times t minus 1. Now, I'm going to be differentiating, so I might as well expand that out. Dx by dt is equal to 1, dy by dt is equal to 2t take away 1. dy by dx will equal y dash over x dash, which is simply 2t minus 1 over 1, or 2t minus 1. Okay, so that's my final answer there. Now, the second derivative goes like this. D squared y by dx squared is equal to d, differentiate the first derivative with respect to t, and then chain rule it out. So times dt by dx. So dy by dx was 2t minus 1. Differentiated with respect to t gives me 2. And we had dx by dt was just 1. So dt by dx is 1 over 1, which is also 1. So my second derivative here works out to be 2. Now, the last kind of bonus thing in here is how, in this case, can we eliminate the t from those two equations? And it's pretty easy because you can make t the subject here. So let's do this just quickly at the end. So x is equal to 1 plus t, which gives me t is equal to x minus 1. Okay, and over here, we've got y is equal to t times t minus 1. And now we've got t written as a function of x. So we've got x minus 1 times x minus 1 minus 1, which gives me a parabola here. That's a 1, crossing at 1 there and crossing at 2 there. So you can see again that we've got that second derivative being a positive number, which means that at the stationary point, we've got a minimum. Okay, right, that is 6.5 minutes is long enough already. When you get into exercise 4E, you will use some of these skills in some of the harder questions. I'm also going to do some exam videos where we are finding tangents and normals to curves with parametric, so that'll be coming up in the next day or so.